Hi, today we'll be studying about vectors. Okay, so first thing that we are going to study in vectors is your translations. Okay, so we'll just understand what translations actually mean in vectors. Okay, so a translation vector in mathematics, it is that vector which describes the movement of any shape or any object from one place to another. Okay, for example, if you have this axis, which is your x-axis and your y-axis, this is your x-axis and this is your y-axis. Okay, so translation of a vector is defined as something. Suppose you have this vector. Okay, you have a vector and this vector has been shifted to another place, which is this. Okay, so I'll just take another pen so that it is easy for you to recognize. We have just shifted this vector to another place without changing its shape or its length. Okay, so this thing, that whatever we are doing by transporting this vector to some other place, to some other location, this is known as your translation. Okay, we are not changing the length of that vector, we are not changing the direction of that vector. Okay, so this is your translation. So it basically means that we have just moved our vector from one location to another location in a plane. Okay, this is your xy plane. Okay, so this is known as your translation. So in this topic, we'll be studying about translations, that how we translate one vector from one place to another. Okay, and we'll also be learning about a subtopic of translations, which is your column vectors. Okay, which is your column vectors. So basically, column vectors are just another representation of your translations. Okay, how we can represent the translation of a vector into written form. Okay, this is your graphical form. So how can we write it in like in pen form or in pen paper format? That is your column vector. Okay, so we'll just learn how to write translations in column vectors. Okay, so basically, first we'll just understand what column vectors are. So, okay, you have clearly understood what translations are. Okay, translations of vectors. Now, if we want to represent this translation in a written format, okay, that format is known as your column vector. We write this vector, which is your translation or your original vector, in column format. Okay, we just make a column like this, square brackets or curly brackets. So it is just a way of writing a vector which can give you information about that vector. Okay, so there are two components in column vectors. There are two components in column vectors. One is your horizontal component, which is the number which is written at the top of your vector, and the second is your vertical component. Okay, the number which is written below the horizontal component. Okay, so we'll just understand. We'll just go through it with the help of an example, so that you have a clear understanding of it. Okay, suppose you have a vector. Suppose you have a vector. This is your vector. Okay, suppose you have this vector and you have to write this vector in your column form. Okay, in your column vector. So now there are many questions asked in your papers to write these translations into column vectors, and also the vice versa, to write column vectors into translation vectors. Okay, so first we have to convert this into a column vector. So this is your question. Okay, so what we'll do, we'll just see the vector and we'll try to make a right angle triangle out of it. Okay, so if I'll make a right angled triangle, okay, just a second. If I try to make a right angle triangle out of it, okay, if I try to make a right angle triangle out of it, so what it will be like, it will be like this. It will be like this. Okay, this is your right angle triangle. We can make a right angle triangle with this vector. Now what we are going to do, suppose we have to write this in column vector. So we know that column vector has two components, the x component, which is your horizontal component, and the y component, which is your vertical component. Okay, so horizontal, for writing the horizontal component first, we'll just take the point of this vector. Okay, what is the point of this vector? It is a. Okay, so we'll just see how many blocks or how many places the vector has been moved in the x direction. Okay, so how many places are there in the right triangle for the x component? There are 1, 2 and 3. There are 3 blocks, so there are 3 places. So we will write 3 as the horizontal component. Okay, now what we'll do, we are at this point and we have to go to point B. Okay, we have made a right angle triangle and we have written the x component of the vector by going in the in the positive direction of the x-axis. Okay, so this is 1, 2 and 3. So we know from this fact, we know from the fact you must have studied that suppose if we have x and y axis, suppose we have x and y axis, so we know that when you go in this direction, this is positive, and when you go in this direction, this is positive. Okay, this is positive x-axis and this is positive y-axis. And when we go here in this direction, this is negative x-axis, and when we go here in this direction, this is negative of y-axis. Okay, so the same thing, the coordinates and the signs that we applied, that we have studied earlier, so we'll just apply these things in our this triangle. So here, if the line segment is going towards the right, so this is positive of 3 because there are 3 blocks. This line segment or this vector is covering 3 blocks. Okay, so we have right positive 3 as the horizontal component. And now from this point we'll go to point B. Okay, so here this is also your positive y-axis, this is also your positive x-axis, so both the components will be positive. Okay, so here this has gone for like 1 2 3 blocks, so this is your positive 3. Okay, so we have just written the column vector for this vector. Okay, this translation vector we have just converted into column vector. Now okay, we'll just take another example. Suppose your vector is like this. Okay, suppose this is your vector. Now what we'll do, we'll just construct a right angle triangle first. So let us first construct a right angled triangle. Okay, so this is your right angle triangle, right? This is your right angle triangle. So here we will just write the column vector for this vector. Okay, for this translation vector, we'll write a column vector. So here, let's cover this line segment first. So how many blocks are there? We are going in this direction. So how many blocks are there? 1, 2, and 3. So it is, since we are going in the right direction, so this is positive of 3. Okay, this is positive of 3. And from here, we are going down. So how many blocks are being covered? 1, 2, and 3. And since we are going down, and we know from the rules of our this coordinate axis that when we go down, this is negative, so this is negative y-axis, right? So 1 2 3, 3 blocks, so -3. Okay, so this is how we convert your translation vectors into column vectors. So you just have to construct a right angle triangle, and then you have to determine the x and the y coordinates. Okay, similarly you can also convert from column vectors to translation vectors. Okay, you suppose you have been given a column vector. For example, you have to construct a translation vector for 2 and 3. Okay, so what you'll do, you'll just see what is the horizontal component for this vector. It is +2. So suppose I'll just take a point over here and I'll go +2 here. Okay, so see, this is your right angle triangle. Okay, this is your right angle triangle. So first we have just constructing our triangle, the base and the perpendicular of the triangle. Okay, your hypotenuse will be your final translation vector. Okay, so we are going 2 places to the right, so this will be like this, 2 places to the right. Okay, and now 3 places to the 3 places upwards, so this is like 3 blocks upward. Okay, so we have converted our so we have drawn the right angle for our vector. Okay, now what will be your hypotenuse will be your final translation vector. Okay, your hypotenuse, what is the hypotenuse for this? The hypotenuse for the for this will be this. So this is your final translation vector. So for 2 comma 3, this red line is your final translation vector. So this is how you can convert between translation vectors and column vectors and vice versa. Okay. Now there's one more concept which we have to cover is your addition and subtraction of vectors. Okay. Now it is very easy. Suppose you have a vector A is equals to 2 and 3 and B is equals to -1 and 4, and you have been asked to do this. You have been asked to find the value of this. So you can simply add the x component with the x component and the y component with the y component. So 2 minus 1, 2 plus -1, the x component, we have added the x component, and 3 plus 4, we have added the y component. So your A plus B will be 2 plus of -1, so this is 2 minus 1, so this is 1, and 4 plus 3 is 7. So this is your final answer. Okay, 1 7. So this is your final column vector when you perform the addition operation. Now similarly, if you have to perform the subtraction operation on these two vectors, so what you'll do, A minus B, you just do the same thing. You just subtract the x components and the y components. So this is 2 minus of -1 and 3 minus 4. So the answer for this will be 2, minus into minus is plus, so 2 plus 1, and 3 minus 4 is -1. So A minus B will be equals to 3 and -1. So this is your final answer. So this is how we perform the operations of addition and subtraction on vectors. Okay. Now you can similarly do this for by depicting them on a graph or by depicting them in your xy plane. You can similarly do that with the help of right angle triangles, which we had studied earlier, which we just have studied. Okay. Now there's one more topic that we'll cover. Actually, there are two more topics that we'll cover in this lecture. The first is your multiplication of vectors. Again, it is very easy. Suppose you have a vector A is equals to 2 and 3, and you have to find out the value of 4A. Okay, you have to find out the value of 4A. So what we'll do, we'll just multiply this 4 inside the vector with the x component and also with the y component. So when you'll multiply, what you'll get, we'll write 4, 2, 3. So this will be equals to 4 into 2 and 4 into 3. So this will be equals to 8, because 4 twos are 8, and 4 twos are 8, and 4 threes are 12. Okay. Okay, this is nothing. So this is the value of your 4A. Okay, 8 and 12. Okay, we'll just multiply the number with the x component and simultaneously with the y component. So you'll get your multiplication. Okay, so this is how we perform the multiplication of vectors. Now suppose you have to find the magnitude of a vector, which is your next topic. Suppose we have a vector y is equals to -1 and 2. Okay, now you have to find the value, you have to find the magnitude of this vector. So for finding out the magnitude, there is a very simple formula. To find out the magnitude, you just have to take the square root of the squares of your x component and the y component, and you just have to add them together. Okay, so this is the formula which you just have to remember for calculating the magnitude of a vector. Okay, now suppose here's your question that this is your vector y is equals to -1 and 2, and you have to find out the magnitude of this vector. So for finding out the magnitude, what we'll do, we'll first take the squares of the x component and the y component. We'll just add them together, and then we'll take the square root. So what is your x component? Your x component is -1, so -1 square, plus your y component is 2, so 2 square, and we'll just add them and take the square root. So this is 1 plus 4, so this is equals to √5. So your √5 is the magnitude of this vector. Okay, now there are a few more topics in vectors which we'll cover in the next lecture.